All right, so in this video, we're going to talk about the difference between the project tool and the define projection tool. So there's instances where you might want to use these. You might have downloaded data and it doesn't have a projection defined and you want to define the projection, or it has the wrong projection defined, or you might just want to take a shapefile that has a projection defined, but you want, because you're doing precision analysis or you want to use another program later, you want to make sure that all of your data are in the same projection. So you want to reproject it into that projection. So there's a number of different reasons to use it, but the project and define projection tool do very different things. And so we want to be really careful and make sure we're using the right one. So the define projection tool is going to basically throw out whatever projection you currently have defined and replace it with another one. So, you know, even if your units are in degrees, you tell it that they're in meters, it's just going to treat them as meters. So it could put your data on the opposite side of the planet. So if that's what you need to do, that's perfect. But if it's not what you need to do, it's dangerous. And then the project tool, you give a new projection that you want your data to be in, and it will transform your data into that projection. So it should still be accurate, even though it's a different one. So to illustrate this, we're going to use both of these tools. And what I have is this map of watersheds around the United States, and I've subset some Virginia watersheds so that we can easily kind of compare a subset and a smaller set of these data to see what the tools do. So the first thing that we're going to do is use the project tool, which shows up right here if we search. And I'm going to input Virginia watersheds, and I'm going to call this Virginia watersheds UTM. So we're in a projected coordinate system, or I'm sorry, we're in a geographic coordinate system right now, and we can look and see that here by going right-click, properties, and in the source, go to spatial reference. So you can see that right now we are in NAD 1983 and degrees. Okay, so we are going to switch to UTM, and we're going to, in order to find that, we're going to click this little Earth looking thing. And this is going to populate with the available coordinate systems for us to convert to. And it'll take a second here. But if you know exactly what you're going to transform into, you can search for it right here. But I'm going to show you how to navigate through the drop downs in this menu so that we can, I can show you how to get to the UTM coordinate system that we want to look at. So this is just taking a second as they load. There's a lot of them to load. Okay, so now we have the, here are projected coordinate systems. We can scroll down and see UTM. And then we're going to choose UTM 1927 and go to zone 17N, which is the zone Virginia is in. Hit OK. And then we're going to run. And so you can see it created a new shapefile. And we're going to change the symbology here so we can compare that to the other one. So our outline color, let's just make it red. And let's make it dashed too. So dashed, red, apply. And we see if we, even if we zoom in really close, they're exactly the same. They're right on top of each other. So because this did this conversion, they look good. Okay. So this is NAD 27. Now what I'm going to do is, using the define projection tool, I'm going to change this from NAD 27 to NAD 83. So it's the same units, it's pretty close, but just a different datum. And because we're doing the define projection tool, it's not going to do any mathematical calculations or anything to transform them. It's just going to say, okay, these data are NAD 83 rather than 27. And so we'll see what difference that makes. So I'm going to go define projection, and our we're going to use the UTM. The reason I'm using the UTM one and not this one is because this is in degrees. If I convert that to UTM using defined projection, the watershed will just be on the other side of the planet, which in a lot of ways is less dangerous. Because remember, you would see that immediately and be like, I screwed up. But this is more insidious because you can end up not realizing the mistake you made. So again, probably should have started talking about that after I hit the little globe thing, since it's takes a second for these to populate. But once they populate, we're going to just navigate to the same through the UTM system, but do NAD 83 instead of NAD 27. Just wait for this to come up. You can tell that your video is not frozen because my mouse is moving around. Okay, so we're going to go down to projected, UTM, 83 this time, 17, okay. And notice the other thing this doesn't create a new shapefile. It just changes the projection of the one that you have. And it also warns you, this tool modifies the input data. So we're going to run. Okay, so zoomed out, looks okay, right? Not too bad. It looks like it did the same thing that the other tool did. But if we zoom in, look at what we see now. So these are all shifted, right? So you can imagine if you're doing an analysis that requires any amount of precision, this is not great. We shifted our watershed boundary. It looks like about 600 or 700 feet. Okay, so this is really important. It might look really close when you're zoomed out, but when you're zoomed in, this is a substantial difference. So the takeaway here is just be really careful. Make sure whenever you're messing with the projections of your data, be sure that you understand whether you want to define the projection or use the projection tool to convert it to another projection.